Okay, so the purpose of these two sections is we now hopefully are pretty decent at truth tables, and so we're going to build off of that. And I think I mentioned that the course captain seems to emphasize these sections more than truth table sections, because what happens here is, as human beings, we tend to kind of make a lot of the same arguments. And so for most of the cases, certainly not all, and that's why I teach truth tables, but for most cases, we can kind of fall into a category of some type of argument. So we're going to talk about that in this section. We're going to talk about a little bit more truth tables in the next section, but also arguments that are very common and whether or not we can believe them or not. And so in this section, we start with talking about equivalent statements. So what this means is that if we are able to symbolically represent things in one form, and we form a truth table, and all of those, the column is that the final column of that truth table would be the same for both of those symbolic statements, then we can say, great, these two things mean the same thing. So in this case, we have, we're trying to show that P or tilde Q and tilde P implies tilde Q are equivalent, which seems weird because those are very different looking like symbols, but let's form a truth table. And so we've seen enough truth tables at this point that I'm probably not going to go through every single column, but here is my truth table. I need my tilde Q, I need my P or tilde Q, I need my tilde P, and then finally I need my tilde P implies tilde Q, or tilde P, if tilde P, then tilde Q. And so I go through this whole process, and the columns that interest me to determine if these two statements are equivalent are the P or tilde Q column, I guess the third one from the end, and then the last one. And notice how they are the same. The third from the last one is true, true, false, true. The last column is true, true, false, true. And so I can conclude that P or tilde Q and tilde P implies tilde Q are equivalent statements. They will be true. One will be true every time the other is true, and one will be false every time the other is false. And so part B tells us that we're going to use the results to take a statement that is equivalent to what is being said. And equivalent is in the sense of logic. Obviously, it's not exactly going to be the same sentence in English, because that would be silly. We would just be repeating the sentence. But logically, these two sentences are the same. And so the first one is, the bill receives majority approval, or the bill does not become a law. So that's my P or tilde Q, which is equivalent to saying that if the bill does not receive majority approval, then the bill does not become a law. So that's my tilde P implies tilde Q. Those are logically the same thing. So if you were having an argument with someone and someone said the P or tilde Q, the bill receives majority approval or the bill does not become a law, it's the same thing as you saying, oh, if the bill does not receive majority approval, then the bill does not become a law. So I think in the bottom left, I kind of took the statement and put it in symbolic notation, which is not a bad way to do it. And then once I have that symbolic notation, it's kind of easier to read off that last column, right? Because if I have P is the bill receives majority approval, Q is the bill becomes law, then now I have my logical or symbolic form. I just translate it back. Tilde P is the bill does not receive majority approval. Tilde Q is the bill does not become law. And so now I can translate it to this equivalent statement. And so this happens a lot. There's one type of equivalent statement that is always an equivalent statement. So if you want to, you can build a truth table for P implies Q, or if P then Q, but that's equivalent to saying tilde Q, or if tilde Q, then tilde P. Those are equivalent, and this is talked about so often that it's called the contrapositive. And I use this in my mathematical homework all the time, because sometimes it's hard to prove that P, if P, then Q. So I might try showing that if tilde P, then tilde Q. So contrapositive shows up so often that if we have a statement, like in here in the example A, we have this statement that you live in Los Angeles, implies that you live in California. If you live in Los Angeles, then you live in California. If P, then Q. Well, that's equivalent to saying that if you don't live in California, then you don't live in Los Angeles. Again, obviously they're not the exact same sentence, but logically they are saying the same thing. If the first statement, if P then Q, is true, then tilde P implies tilde Q is also true, and vice versa. If P then Q is a false statement or returns a false result, then tilde Q, or then if tilde Q, then tilde P will also imply, or will also return a false statement. I guess stacked a logic statement and a logic statement. But the important thing here is that if I built a truth table, they're going to have all of the same results. These are equivalent statements. Now, I guess I kind of skipped ahead. There are kind of these relationships that show up so often that we give them their own fancy names. So the conditional is the if P then Q. We've seen that before. The converse of that is if we flip those two values. So if we have a logical statement if P then Q, then the converse of that statement is if Q then P. The inverse of that statement is tilde P, or if tilde P then tilde Q, and the contrapositive of that statement is if tilde Q then tilde P. And this is definitely something I would put on your note card, because I seem to recall there was a couple of questions on the test that wanted you to take a statement and translate it into all of these different forms. Now, it's worth mentioning these are not all equivalent to each other. In fact, some of them are almost opposites of each other. But we talk about these things so often when we're relating a symbolic form of, okay, I see you have your conditional argument. What is the converse of that conditional argument? What is the contrapositive of that conditional argument? That they get their own special names. And you should be able to take a sentence and translate it into these different forms. So for example, let's take a statement. If it's a BMW, then it's a car. We don't have the then, but it's applied. So that's my conditional statement. If I want to write that as a converse statement, well, I just flip the statements. So if it's a BMW, it's a car. The converse of that, if it's a car, it's a BMW. And this is kind of what I was talking about. Certainly the conditional statement is true. The reverse is not always true. There's a lot of examples that make that so it's not true. So conditional statements and converse statements are not equivalent statements. Similarly, if we talk about an inverse, we take our conditional statement, we just slap negations on both of our statements. So originally we have if it's a BMW, then it's a car. And so the inverse is if it's not a BMW, it's not a car, which again is not equivalent to conditional, but they have important value in logical relationships, so we need to be able to fluidly translate. And so this is what I'm talking about on the test. You'll probably have a question that gives you a conditional statement, and then we'll say, give me my converse, give me my inverse, give me my contrapositive, and you should be able to translate through. If you don't see where or how I'm translating these so quickly, write them as symbolic notation. Write your, if it's a BMW, it's a BMW as your P, it's a car as your Q, and then look at your table and do the translations that way of, okay, I have my symbolic notation, I know what my P is, I know what my Q is, so if I take the tilde P or the tilde Q of that, it's very easy for me to take those symbolic statements and flip them, negate them. So that's an option. You don't have to do that. Some people are pretty good at translating these things in their brains, but that would be the intermediate step, that if you don't see the jump from your conditional statement to your converse statement, translate it into symbolic form first, and then write the required or the desired statement. And so we actually can talk about what relationships are equivalent and which ones aren't. And we already talked about how conditional and contrapositives are equivalent statements. Here's a truth table of both of them. So there's returning the same result in every row. And in fact, the converse and the inverse are equivalent to each other.
So conditional is not equivalent to converse. It is not equivalent to inverse, but converse and inverse are equivalent to each other, because we can look again that each row has the same value as or has the same truth value. True, true, false, true, 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 false, true. And so those two statements are equivalent. So let's see another example of how to write these variations of our conditional statements, our contrapositive, our inverse, and our converse. So we have a statement here, similar to the BMW example. If you are 18, then you are not eligible to vote. Well, let's say my P is that you are 17. Let's say my Q is that you are eligible to vote. And so my conditional statement would be P implies tilde Q, or if P, then tilde Q. Again, we kind of have the English translation here. If you are 17, then you are not necessary, or you are not eligible to vote. And so if I'm going to write the converse of that statement, well, I flip both values. So it was originally if P, then tilde Q. Now it's tilde Q, or if tilde Q, then P. And to translate that back to English, okay, well, tilde Q is that you're not eligible to vote. P is that you are 17. And so if you are not eligible to vote, then you are 17. So all I did was swap the order of my previous statement. If I want to write my inverse, I negate both of those values. So originally I had if P, then tilde Q. I will negate both of those things, which will give me tilde P implies Q. And it kind of notice it writes here, which is actually kind of helpful, that if you negate a negation, you will return kind of the affirmative of that statement, which makes sense logically, but it's kind of nice to mention here. So yeah, I flipped my P to become tilde P. I flipped my tilde Q to become Q. I didn't change the order of my statements. So that's going to translate roughly to, if you are not 17, then you are eligible to vote. Not roughly, that's the exact translation. And then finally, for contrapositive, this is the weird one. We flip the order of P and Q, and we flip or we negate both of those values. So originally we had if P, then tilde Q. Now we are going to have if Q, then tilde P. And again, kind of the nice thing about this table is it double negates our Q, but my brain works better to say, okay, it was false, or it was a negation. Now I'm going to turn it into an affirmative. I'm just going to drop the negation. So whatever helps you keep it straight. And so if I flip my statements and I change the truth, well, it's not really the truth value, but if I negate both of my statements, then originally I had if you are 17, then you are not eligible to vote. And now my contrapositive tells me that if you are eligible to vote, then you are not 17. And if we want to apply truth values, like in this case, if you are 17, you are not eligible to vote, that is a true statement. It's just a law that we have. And so the only relationship that is absolutely true is if you say that statement and someone's like, wait, okay, I'm confused. So are you telling me that if you are eligible to vote, then you are not 17? Yep, that is equivalent. Those are true statements when they're true. They are false statements when they're false. So in this case, they're definitely true. So they are equivalent. People that are not eligible to vote and aren't 17, like 16-year-olds, 15-year-olds. And similarly, if you are not 17, then you are eligible to vote. That is also not true. Same thing, same logic, same group of people don't work. 16-year-olds aren't eligible to vote. 15-year-olds aren't eligible to vote. There are people over 18 that aren't eligible to vote. I believe prisoners fall into that category. There might be some other examples, but I can't really think of them off the top of my head.